Hey everybody, we're going to start a whole new topic now. We're done with logic and we're going to spend maybe one lecture just on the XY coordinate system, plotting points, graphing lines, and finding solutions to equations. Here we introduce the x-axis, it's a horizontal line, and the y-axis, it's a vertical line. And notice that the x-axis passes through this point, y equals 0. And what that means is that the y-coordinate of every point on the x-axis is 0. So another way of describing the x-axis is to say that the x-axis is the line where y equals 0. Now I can do something similar with the y-axis. It turns out that the y-axis is the line where the x-coordinate of every point is 0. So every point on this line has an x-coordinate of 0. And so this point, this is on the x-axis and the y-axis. So this point has an x-coordinate of 0 because it's on the y-axis, and it has a y-coordinate of 0 because it's on the x-axis. Okay, we seem to be on a roll, so let's keep going. This horizontal line that runs through the point y equals 0 on the y-axis is the x-axis, but it's also given by the equation y equals 0. So, what do you think we'd call this line right here that runs through the point 6 on the y-axis? You guessed it, y equals 6. And what that means is that the y-coordinate of every single point on this line is 6. The x-coordinates can change on this line, but the y-coordinate of every single point on this line is y equals 6. And this line down here, this line that runs through -6 on the y-axis, this is the line y equals -6. The y-coordinate of every point on this line is -6. And just to do one more example to be thorough, let's take this line right here. It runs through the point 3 on the y-axis, which means that the y-coordinate of every point on this line is y equals 3. So the equation of this line that runs through 3 on the y-axis is y equals 3. Now I guess we have to do the same thing for the x values, don't we? We can do something similar with points on the vertical lines. This vertical line that runs through the point -6 on the x-axis is given by the equation x equals -6, which means that every point on this vertical line has an x-coordinate of -6. And let's look at this vertical line. This vertical line passes through -3 on the x-axis. So every point on this line has an x-coordinate of -3. And we describe this line by saying this is the line x equals -3. And so forth. Now, we'd like to move on to bigger and better things. So we're going to be plotting ordered pairs of numbers. Here we have pairs of points, and we say that they're ordered because the order in which the numbers appear is significant. The first number of the pair represents an x value. The second number of the pair represents a y value. So this ordered pair of numbers represents the point in which x is equal to 3 and y is equal to 2. Can we find that? Well, here's x equal 3 on the x-axis. So every point on this vertical line has an x-coordinate of 3. So all we have to do now is find y equal 2, and here it is. Here's y equal 2 on this horizontal line. This horizontal line, y equal 2, and this vertical line, x equal 3, meet right at this point. So this is x equal 3, y equal 2. Our next ordered pair, x equal -6, y equal 2. And remember, it's always x first and y second. So x is -6 and y is 2. Here's the line going through the point -6 on the x-axis. So this line right here, this vertical line corresponds to x equal -6, and we want y equal 2. So we go to the point y equal 2 on the y-axis and go horizontally until we meet the line x equals 6. So here's x equals 6, here's y equal 2, x equal -6 rather. And there's the point -6, 2. Now let's try another one. Remember, x is first, so this is x equal -5. I'm sorry, x equal +5, y equal -3. So we look on the x-axis for the point x equal 5, and this is the line x equal 5. And on the y-axis, we look for y equal -3, here it is. And we go horizontally until we hit the line x equal 5, y equal -3, x equal 5. They meet right at this point, and it's always x first, x equal 5, y equal -3. One more point, x equal -4, y equal -2. So the first thing we do, we find -4 on the x-axis, and here it is. So this line that goes through the point x equal -4 on the x-axis is the line x equal -4. We also want y equal -2. So we find -2 on the y-axis, and we go horizontally until we meet x equal -4. Here's x equal -4. And this point, x equal -4, y equal -2. Now I know you already knew that. This is just a refresher. Okay, let's look at this. An ordered pair of values, AB, where A is a value of x and B is a value of y. An ordered pair of values, AB, is said to satisfy an equation in the variables x and y if the equation is a true statement when we plug in A for x and B for y. So when we plug in A for x and we plug in B for y, if the equation is a true statement, then we say this ordered pair of values satisfies the equation. Let's look at an example. Determine which ordered pairs of values satisfy the equation 3x plus 2y equals 10. And we have 4 candidates here, 4 ordered pairs of values. And some or all of those may satisfy this equation. We have to check each one. So we'll take 3 and plug it in for x, and we'll take 2 and plug it in for y. And what do we get? 9 plus 4 is 13. So no, this is false. Let's try this pair of values, x equal 2, y equal 2. We'll plug them into this equation for x and y. So we'll have 3 times 2 plus 2 times 2. This is 6 plus 10, 6 plus 4 equals 10. Okay, that's true. This pair of values, I'm going to circle it because it does satisfy the equation. Now let's try 0, 5. 3 times 0, x is 0, plus 2 times y equal 5, and we get 3 times 0 is 0, 2 times 5 is 10, and oddly enough, that's true. This is true. So this pair of points satisfies the equation. And we'll try one last set of x and y values, x equal 1, y equal 4. And we take x equal 1 and plug it in for x, and we get 3 times 1. And we take 4 and plug it in for y, plus 2 times y, which is 4. And we get 3 plus 8 is 11. Nope, that's not equal to 10. So this is false. So the ordered pair of values 1, 4 is not a solution. So what's our answer? These two sets of points satisfy the equation. The other candidates don't, so this is our answer. Okay, we're going to do a little bit of graphing now. And I guess I should actually define what a graph is. The graph of an equation is the set of all ordered pairs AB, where A is an X value and A is an X value and B is a Y value. So it's the set of all ordered pairs, X value A and Y value B, that satisfy the equation. So that's what the graph is. It's the set of all ordered pairs that satisfy the equation. And one way that we can graph an equation or construct the graph of an equation is to plot some points and then connect them. Here in this example, we're told to graph the equation y minus 4x equals 8 by plotting pairs of points. And we're going to be graphing lines. So let's see, if we heard the expression 2 points determine a line, or a line is the shortest distance between 2 points. If we have 2 points, that's enough. We might want to get a third point just for verification to make sure that the first two actually do work. Now, when we plot points, we're going to go the easy route. What could be easier than plugging in 0 for x and seeing what y is? So, I'm going to plot 0 for x, or plug in 0 for x, and that means I have y equals 8. Oh, we know what y is. When x is 0, y equals 8. Okay, there's one solution. We've used up one of the easy cases. Now there's another one. Instead of letting x equal 0, we can let y equal 0. And if we have y equals 0, that leaves us with negative 4x equals 8. So we have negative 4x equals 8. And we're looking for x, so we divide both sides by negative 4. And we get x equals 8 divided by negative 4, and that's negative 2. So when y is 0, x equals negative 2. And we should probably take one other point. Now the easy cases are gone. X equals 0, y equals 0. For lack of anything better, let's say x equals negative 1. Why negative 1? Well, it's late and I can't think, and that's the only thing that came to mind. So if x equals negative 1, then we have y minus 4 times negative 1 equals 8. And so that means that y plus 4 equals 8. And so I'm looking for y. I'll subtract 4 from both sides, and that means that y equals 4. Okay, when x equals negative 1, y equals 4. So hopefully that will work. And now let's plot these pairs of points. X equals 0. So let's see, where is x equals 0? Oh my goodness. I drew the xy coordinate system and I didn't put any numbers down. Well, this is 0, 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4. Oh my goodness, I must be asleep on the job. Yeah, 1, 2, 3, 4, 5, 6, and this is y equal negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, wow. Putting up the xy coordinate system and not labeling the points on the axes is sort of like leaving the house without your pants on in the morning. My goodness, what was I thinking of? Okay, now we really are ready to go. And I never do that, by the way. I've been married for a long time, and my wife makes sure I'm dressed before I go out the front door, thank goodness. Okay, x equals 0. So this is x equals 0, this line right here. And y equal 8. Whoop, we got to go up a couple more. Okay, x equals 0, y equal 8. So 0, 8. Let's plot another one. X equals negative 2. And here's x equal negative 2 and y equals 0. Okay, this axis, the x-axis is y equals 0. So negative 2, 0, that's another point. And x equal negative 1, y equal 4. Here's x equal negative 1. Here's y equal 4. Negative 1, 4. Now, if we've done our job right, these points should all lie on the same line. Let's just connect them and make sure that that happens. Yeah, looking pretty good. Looking pretty good. Sure is. Okay. And from our graph, let's see, here's another solution right here. X equal negative 3, y equal negative 4, and we picked that out just because this is a point on the line. Okay, very good. Now, it turns out that every single point on this line is a solution to this equation. It just happens that most of the solutions are represented by numbers that aren't whole numbers. For example, right here, now let's see, what is this? Y equal negative 2, okay. Well, that's a whole number. But x, it's between negative 2 and negative 3. So actually, what's between negative 2 and negative 3? Negative 5 halves? Yeah. So this line is the set of all solutions. We've graphed the solution to this equation. And typically the way to do it, find 3 points on the graph. Just pick a value of x and find the value of y. Or pick an easy value of y, like y equals 0, and find the corresponding value of x. Plot the points, and that gives us the graph. And notice that in this case, we were able to take some really easy points to plot, like x equals 0 and y equals 0. They don't always work, but when they do, we want to go for them. It makes life easy for us. Here's an important concept, the x and y intercepts. They're important because they make it easy to graph most lines. And the y-intercept of a line is the point on the y-axis where the graph of the equation crosses the y-axis. We could say maybe it's the y-intersect of the graph or the line. You know what? I said the y-intercept of a line, so maybe I should just limit the conversation to line, okay? The y-intercept of a line is the point on the y-axis where the graph of a line crosses the y-axis. So this is where the line and the y-axis intersect. And notice something. The x-coordinate of the y-intercept is 0. And this is not a misprint. The x-coordinate of the y-intercept is 0. For example, here's a line, and here's where the line crosses the y-axis. But look which coordinate is 0. X is 0 here. This is the y-intercept, but x is 0. Similarly, the x-intercept of a line is the point on the x-axis where, and you know, in old days, this used to have an E on the end, W-H-E-R-E. Okay. The x-intercept of a line is the point on the x-axis where the graph of the line crosses the x-axis. Well, here is where the graph of the line crosses the x-axis. So this is the x-intercept, but look what's 0. It's the y-coordinate that's 0. So at the x-intercept, and let me underline that. At the x-intercept, the y-coordinate is 0. And for the y-intercept, the x-coordinate is 0. Now, this is important because an easy way to graph a function is to find the x and y-intercepts. And to find the y-intercept, we let the x-coordinate be 0. And to find the x-intercept, we let the y-coordinate be 0. And let me just write that down for emphasis. This is important. Remember in one of the examples that we did a few minutes ago, to find 2 points on the line for graphing, I let x equal 0 for one and found the y-coordinate, and I let y equal 0 for the other point and found the x-coordinate. I was finding the x and y-intercepts when I was doing that. So this is an easy way to graph a line, as long as the graph is not horizontal or vertical. Time for another example, I think. Okay, good example. Graph the line that is given by the equation 3x minus y equals negative 6. And we'll find the intercepts. First, we'll find the y-intercept. And to do that, we let x equal 0. So that means we have 3 times 0 minus y equals negative 6. Now what does this become? 3 times 0 is 0. So we have negative y equals negative 6. But I want y. So I guess what I'll do is I'll multiply both sides by negative 1. And I'll get positive y equals positive 6. Y-intercept. Okay. Now I have to do the same thing for the x-intercept. And I let y equal 0. For the x-intercept, I let y equal 0. In our equation, 3x minus y equals negative 6 becomes 3x minus 0 equals negative 6. So that gives us 3x equals negative 6. And I divide both sides by 3, so that'll give me x equals negative 6 divided by 3, that's negative 2. Here's my x-intercept. Now, am I done? I'm not, because the instructions said graph the line given by this equation. So I'm going to summarize what I've accomplished so far. The y-intercept is y equals 6. And the x-intercept, x equals -2. Okay, so I just recorded the information that I found. And here's my y-axis. And here's my x-axis. 1, 2, 3, 4, 5, 6. Y equals 6, the y-intercept, y equals 6 is one of the points on the graph. And x equal -2 is another point. I'm going to have to move this. So here's x equal -2 on the x-axis. Y equals 6 on the y-axis. The graph of the line goes through the two intercepts. And 2 points on a line are sufficient to graph the line. So here's my line. This is the line 3x minus y equals -6. It's inevitable when we're dealing with lines that we are eventually going to talk about slopes, so we might as well do it now. The slope of a line measures the steepness of the line, and the symbol for slope is m. And here's how we compute the slope. If x sub 1, y sub 1 is a point on the line, and x sub 2, y sub 2 is a point on the line, then the slope is given by y2 minus y1 over x2 minus x1. And notice what this is. y2 and y1 are the y coordinates of the point, of the points. So y2 minus y1 is the change in the y coordinates. And x2 and x1 are the x coordinates of the points. x2 minus x1 is the change in the x coordinates. Now, let's look at a couple of examples computing slope. Okay, here we have a few examples. Determine the slope of the line through the given points. So here are our given points: x1, y1, x2, y2. And remember the formula for slope. M equals y2 minus y1, the change in y, y2 minus y1, over the change in x, x2 minus x1. So y2 is 9, y1 is 4, x2 is 6, x1 is 3. So the slope is 5/3. Next example. Here's our first point, x1, y1. Here's our second point, x2, y2. And slope is given by the change in y, y2 minus y1, over the change in x, x2 minus x1. And y2 is 6, y1 is 6, x2 is 5, x1 is 2. So that's 0 over 3, which is 0. M equals 0. And maybe I should pause here just so that we know what this means. The slope is 0. What that means is that the line is horizontal. And it passes through the point 6 on the y-axis. So this is a horizontal line, and the y-coordinate of every point on this line is 6. So when we have a 0 slope, the line's horizontal, and the y-coordinate of the 2 points is going to be the y-intercept. Okay, more examples. 3, 8, and 5, 4. Find the slope. So we have y2 minus y1 over x2 minus x1. And y2 is 4. y1 is 8. x2 is 5. x1 is 3. And you know, I guess I should have labeled these. x1, y1, x2, y2. There we go. So y2 minus y1 is 4 minus 8. And x2 minus x1 is 5 minus 3. So what do we have? Negative 4 over positive 2. Negative 2. Slope equals negative 2. Negative slope. You know, I think when we finish this exercise, I'm going to have to comment about positive slope and negative slope. One last example. 4, 7 and 4, 11. So this is x2, okay. And slope is m equals y2 minus y1 over x2 minus x1. y2 is 11, y1 is 7, x2 is 4, y1 is 4. So we get 4 over 0. What do you make of that? 4 divided by 0. Well, that's undefined, isn't it? And when the slope is undefined, that means we have a vertical line. Undefined slope, vertical line. And that vertical line will pass through the x-coordinate 4. Something else I guess I should mention. I did mention positive slope and negative slope, didn't I? Okay. Okay, here's a couple of examples. Positive slope. Any line that has positive slope, the line goes uphill from left to right. So here's a line that has positive slope. As we move along the line from left to right, the line goes uphill. And if we compute the slope, we'll let this be x1, y1, x2, y2. So the slope is y2 minus y1, that's 4 minus 0, over x2 minus x1, 0 minus a negative 4. And the slope turns out to be positive. And that's reflected in the fact that the graph goes uphill as we move from left to right. Negative slope. A line has negative slope if the line goes downhill from left to right. And notice as we move along the graph from left to right, the graph does go downhill. And if we compute the slope, we should get something negative. So we'll let this be x2, y2. We'll let this be x1, y1. So y2 minus y1, that's 0 minus 4. x2 minus x1, that's 4 minus 0. We crank that out and we get a slope of negative 1, which explains why the graph goes downhill from left to right. Okay, now we get to some really good stuff. The slope-intercept form of an equation of a line. An equation of the form y equals m times x plus b is the slope-intercept form of the equation of the line. And m is the slope of the line, b is the y-intercept. And let's look at this example. We have it in the form of y equals some constant times x plus another constant. Well, this 3 is our y-intercept m. No, I beg your pardon. This 3 is the slope m. 2 is the y-intercept b. So slope equals 3. Y-intercept equals 2. And can we graph this thing? You better believe it. You had better believe it. The y-intercept is 2. So let's put that right here. And the slope is 3. And remember, slope m equals change in y over change in x. So if m equals 3, and we let the change in x be 1, then change in y is going to be 3, isn't it? Change in y divided by 1 is just the change in y. So we have the change in y equals 3. Now here, x is 0. Here, x is 1. So as x changes from 0 to 1, y changes 3. It's got to go from 2 to 5. And see that? When we go from this point to this point, x changed from 0 to 1. That's the change in x. But y changed from 2 to 5. That's the change in y, 3. Now, can we do it again? Sure we can. Change in x is 1. Change in y is 3. So we go over 1. We go up 3 to the next point. And this is going to be 2, 8. And sure enough, they're all on the same line. So this is how we can graph the line y equals mx plus b. And let's just review what we did. The first thing that we did was we plotted the y-intercept. And then we used the fact that the slope was 3, which means the change in y over the change in x is 3. So if x changes by 1, the change in y is 3. Change in x, 1. Change in y, 3. That takes us from 0, 2 to 1, 5. Okay. Now let's go the other way around. Let's take a line and see if we can get the slope-intercept form of the equation of the line from the graph of the line. Okay, we got ourselves a line here. Kinda, sorta. Okay, we got ourselves a line, and we got to start someplace. And I'll tell you what I noticed right off the bat. I noticed that where this line crosses the y-axis is at y equal 4. So 4 is the y-intercept. I noticed that right off the bat. So the y-intercept b equals 4. Now, we need the slope, don't we? And this point has an x-coordinate of 2 and a y-coordinate of 0. This point has an x-coordinate of 0 and a y-coordinate of 4. So I have 2 points. I can compute the slope. I'll call this one x2, y2. I'll call this one x1, y1. And in case we're concerned, could I have switched them around? Could I have called this one x2, y2 and this one x1, y1? Absolutely. And I'd get the same result either way. The only trick is, once we call one point x1, y1, we just stick with our convention, and we call the other point x2, y2. So let's see, what is slope? That's y2 minus y1. And let's see, I should also write letter m, because m represents slope. So slope is the letter m, and that's y2 minus y1 over x2 minus x1. So y2 is 0, y1 is 4, and x2 is 2, x1 is 0. So our slope is negative. And just to reinforce something that we did a few minutes ago, notice that we have negative slope, and notice what the line looks like. As we move along the line from left to right, it goes downhill, doesn't it? Negative slope. Okay. Now, this exercise asks us to give the slope-intercept form of the equation of a line. Y equals mx plus b. And m is negative 2, so we have y equals negative 2x. And b, what was b? B is 4. Y equals mx plus b. That's it right there. That is it right there. And we have a lot of review material to work on for lines. I will send you out a bunch of homework exercises to work on right after I post this video.